Last two lectures I have solved two problems. Just for a review, foundations, shallow foundations in sand, shallow foundations in clay. First example was shallow foundation in sand. Here nothing has been assumed, rather in this case if you look at here, these have been based on the fields data or the bore logs. First one what we have solved, there is a building, in the building there are interior columns. This interior column have a load 1.95 or 1950 kilonewton dead load plus live load, as well as there is one exterior wall and there are two boreholes, one is nearer interior column, the borehole is here, and exterior wall another borehole is there. Water table and all properties has been given. So, the calculation has been made for borehole 1 and borehole 2 based on your SPT and N cumulative has been calculated, and looking at the profile where we are getting a consistent value of N value, so that within that region this pressure bulb should cover. Once you know the zone of influence of the pressure bulb, automatically your dimension will come into picture, automatically your depth of the foundation will come into picture. So, based on that your size of the footing is 3.25 by 3.25, and at the same time I have also checked whether this bearing capacity has been satisfied. Also you can check whether the settlement, permissible settlement 25 mm has been satisfied or not. Then one more problem I have solved. For the case of shallow foundations in clay, I have explained for purely cohesive soils phi is equal to 0 and n gamma is equal to 0, and it is nothing but if I write it, soil bearing pressure is directly proportional to your QU. There are charts available NC versus dF by B, and I have also explained there are two steps. Step 1 is your assuming allowable soil pressure is equal to soil bearing pressure, find it out what is the dimensions. Once you get your dimensions, then with these dimensions check your permissible consolidation settlement at any stage. Suppose at any stage if it is not satisfied, then you modified the value of the B. So, this case one example I have solved last class. There is a case and there is a column, interior column, load is 510 kilonewton and all other properties has been given. There is a CPT value and QU is given and average QU value has been given. So, based on that, so for step 1 we have calculated the dimension size of this foundation is your 2.4 meter by 2.4 meter. Remember, anything has not been assumed. Based on the subsoil profile, the design has been made. Then while going to your settlement check, it has been observed that the settlement is not coming within the permissible limit. That means it has been given maximum settlement should be 150 mm. So, it is coming out to be 251.7 mm. So, it is not okay. So, based on that B value has been modified and the B value comes out to be 4.45 by 4.45 meter. Taking into these dimensions, you can check yourself. This is for you kind of a home assignment. You can check whether with these dimensions, whether this foundation is going to satisfy the bearing capacity criteria as well as settlement criteria. This is what I have gone through. Let us come to one more problem, interesting problem. I will solve one by one few examples. Go to the example 3. So, in example 3, rows of column in a building has been given. Let me put it in this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, then here also in between I put it. Now, this is the dimension has been given. So, if you look at the dimension of individual column has been given, it is kind of 550 in this row, this is your 600, this is again 600, this is your 500, this is your 500 kilonewton, and this dimension is given 4 meter at the rate of 3.5 meter, here 4 at the rate of 4.5 meter. So, what does it mean? 4 at the rate of 3.5 meter, that means distance from here to here is 3.5, 3.5, 3.5, 3.5 equally. So, this is total 4, 1, 2, 3, 4, maybe my drawing is slightly wrong. So, it will be 3.5 meter each, here 4 at the rate of 4.5, 1, 2, 3, 4. Now, there are rows of the columns. Now, what else it is given? It is also given subsoil profile. Let me draw the subsoil profile. This is your depth in meter, this is 0, this is your 1 meter, and supposed to be a footing. I do not put it what kind of foundation it is supposed to be. Then here it is 3 meter, here it is 12 meter, and there are two zones. If I can write it, water table located at below 1 meter, this is your ground surface, let me put it and this is zone 1 and this is zone 2. In zone 1 it is brownish grey silt clay. Here gamma is given 19 kilonewton per meter cube, Cu is equal to 35 kilonewton per meter square, Cc by 1 plus E0 which is equal to 0.06. Let me extend it also this one. Here it is grey organic clay, gamma is equal to 18 kilonewton per meter cube, Cu undent cohesion is equal to 20 kilonewton per meter square, Cc by 1 plus E0 is equal to 0.15. This is what the subsoil profile has been given, and This is what your column, expected column loads supposed to come, rows of columns are there, and there is a building of L shape. If you look at here, this is a kind of L shape building has to be constructed. You can solve this problem many ways. You can solve the problem many ways. How? Considering each column load, you can consider as one of your isolated footing. Isolated footing means, suppose here one column is here, suppose for example here it is there. I am taking this row. This column is your 550 kilonewton load. Here it is 600 kilonewton. Here it is also 600 kilonewton. The distance is 3.5 meter. The distance is 3.5 meter. You can do it, and individually also you can find it out. First, considering this with your subsoil profile, this is a very long problem. Considering this with this subsoil profile, you can find it out the width of the foundations. It may be any size because no assumptions. So, once you get the width of the foundations, then you apply for your pressure intensity because load of the column is given. This is your pressure valve. Consider second one as if it is one of the individual isolated footing. Take the subsoil profile and find it out the dimensions. Again plot your pressure valve and look at here whether the two isolated footings, is there any overlap of pressure valve or not. If there is any overlap of the pressure valve, then it is not you are not going to recommend for an isolated footing. Then what else left? Once isolated footing has gone, go for a combined footing. Combined footing again many types, either you can combine with a strip foundations, or you can go for a raft foundations, or you can go for a kind of rectangular loaded foundations, considering here because this space here may not be available, this space here may not be available, this space here may not be available. So, let us try with this a row of the foundation, first one strip foundations or a row of the foundations. If I take the row of the foundations, so let me put it in such a way that I am covering one, two, three, four, five columns in a row. This is called your strip. So, then based on that what will happen? I am taking a strip here, foundations, over the foundations all your column loads are acting. That means it has a one size, and once you take it, suppose this is a one row, similarly you can take it, this is another row here. If there are two rows, then you check also pressure valves. This pressure valve will go like this. Here you can take pressure valve, here you can take the pressure valve. Whether this pressure valve superimpose or not, that also you can check. If it is superimposed like this, then the strip foundations also or combined in a strip is not going to be recommended. Then what else left? First you have tried for isolated foundations, then you have tried for strip, then there is no alternative rather than you can go for raft foundations. Let us start with the strip. So, total load Total load I can put it Q net for this strip. Let us put it, this strip is A and this is B, because anyway it is same A, B, C. If I am putting another strip here, these are the same load intensity coming. 550, 600, 600 plus 500 plus 500, which is equal to 2750 kilonewton. Now, with this 205 kilonewtons, how do you find it out your dimensions? How do I take the dimensions? You have to identify the dimensions. Look at the dimension how I am taking. 4 into 3.5. Here 4 at the rate of 3.5, because this spacing, this spacing, this spacing, this spacing completely included. 4 into 3.5 plus here if it is 3.5, the distance is 3.5. Here generally I have to, if this is my B, here it will be generally taken by B by 2. Here is generally we take it by B by 2. So, then it will be 3.5 divided by 2, it will be 1.75. So, rather I put it 1.5 into 2. These are my dimension calculations. How it has come 4 into 3.5? Center to center distance is your 3.5, here to here distance is your 3.5, here, here, here. 1, 2, 3, 4. So, that is why 4 into 3.5 plus 1.5 into 2, which is equal to 17 meter. Now, what should be the width? Length I got it. This length is 17 meter. So, width will be generally, if I take it here, this will be kind of, you can put it in this way also B by 2, here to here also B by 2, or here to here also half, you can take it B by 2, B by 2, it will be B, approximately it will be B. So, B is your 3.5, you can consider width, it is your length, you can consider width is equal to say 2.5 meter. So, size is equal to 17 meter into 2.5 meter. Now, total load intensity is known. Now, find it out Q net. Q net is equal to 2750 divided by 17 into 2.5, which is equal to 65 kilonewton per meter square. In this case, depth of the foundation, because this is a shallow foundations, depth of the foundation initially you start with an assumptions. Water table is located at what? 1 meter. So, generally what depth of the foundation people generally assume or taken? Generally depth of the foundations which is equal to either 1 to 1.5 meter. Because water table is located at 1 meter, I assume or I take it depth of the foundation say 1 meter, say. Do not want to put below the water table, because what will happen, why it has been taken 1 meter, what will happen beyond 1 meter, because you have to excavate, because water table at 1 meter, you have to excavate, so that your concreting steel or caging, it has to be prepared here, then you have to go for concreting, then refill it. If water table is there, then if you go beyond water table, then you have to take out the water by pump out, then do it. So, now size I got it, depth of the water table I got it. Let us start with this design. Now, one size is 2.5 meter by 17 meter, say B is equal to 2.5 meter, and here it is going in this directions, it is your 17 meter. Now, as it is 2.5 meter, 2.5 meter, try to understand 2.5 meter. So, if I go up to 2 times B, 2.5 into 2 is your 5 meter. Let me draw the pressure valve. So, total will be 5 meter, considering it is your 2 times B, and this is my B. So, once it is 5 meter, that means first 2 meter one soil layer, the next 3 meter another soil layer. Fine. Here it is A, here it is B at the middle. Almost 50% of the soil, 50% of the soil is coming one of the subsoil profile, another 50% is coming another subsoil profile. So, in that case, better to consider average value. So, Cu average two into 35, here it is 35 is given, plus 3 into 20, 3 into 20 divided by 5, which is equal to 26 kilonewton per meter square. That means, I have considered only one Cu value, and considering this one Cu value, you can go for both way, this side as well as other side also you can go it, you can find it out. But instead of doing that, considering only one Cu value, that would be better way of designing you can go. Then let us go for your NC. NC is nothing but what? We have a formula, because at the surface is your 5, it is 1 plus 0.2 dF by B into 1 plus 0.2 B by L, and it comes out to be 5.6. Depth of the foundation dF, this is my depth of the foundation, B 2.5, B is equal to 2.5, L is equal to 17 meter, this distance you can put it as L. Come to the next step, find it out Q ultimate N, net ultimate or net safe ultimate CNC by factor of safety, because subsoil profile is your purely cohesive soil, there is no phi, it is purely cohesive soil, there is no phi. So, then it comes out to be 145.6 divided by 2.5, whatever is your divide 145.6, I am not putting it a factor of safety. Q net I am taking it CNC, not safe, Q ultimate net I am taking CNC, which is equal to 26 into 5.6, which is equal to 145.6 kilonewton per meter square. Now, factor of safety 145.6 divided by 65, this is your Q ultimate net soil, and where is your 65? Look at here, Q net load intensity is your 65, then the factor of safety comes out to be 2.24, which is less than 2.5, then not okay. Then what is the next step? Next step has to be, you have to increase the size at least B. B means you have to increase this B, this size has to be increased. Let us start with this. Then modify the dimensions. Modify the dimensions. So, let us say B is equal to 3 meter. Then NC comes out to be NC is from here. Here is your NC. Using the same equations, NC comes out to be 5.52, right. Then CU average has to be changed, because once it is a 3 meter, then it will become a 6 meter, 2, 4. Then is your CU average two into 35 plus 4 into 20 divided by 6, which is equal to 25 kilonewton per meter square. Now, CNC is equal to 25 into 5.52, which is equal to 138 kilonewton per meter square. Now, Q net 2750 divided by 17 into 3. Q net has to be changed. If you look at Q net 2750, total Q load and dimension is changing, Q net also changed. So, it will be 17 into 3, length is 17, width is your 3, and with this 17 into 3, this comes out to be 53.92 kilonewton per meter square. Now, look at your factor of safety. Factor of safety is your Q net soil by Q net structure, which is equal to 138 divided by 53.92, which is equal to 2.55. It is okay. Now, this part is okay. So, let us go to the other part. What are the things to be done? Bearing capacity part is okay. Now, we will go for settlement part. For settlement part, check for settlement, that means what are the things has been given. Qn is your 65 kilonewton per meter square, B is equal to 3 meter, L is equal to 17 meter, and all other value will take it from subsoil profile. Settlement calculations I will discuss in the next class. Thank you.